This tutorial will illustrate a few of the modal analysis features available within SAP 2000. SAP 2000 offers several different ways for defining masses. The masses used in the program are typically available from either object material properties, applied loads, or assigned masses. For the first option, the define materials command allows us to specify a weight per unit volume for each material type, which the program divides by gravity to calculate a mass per unit volume. This mass per volume is multiplied by the volume of the objects and then lumped by the program at the joints. One of the unique features of SAP 2000 is its ability to calculate mass from applied loads. Only loads in the negative z direction may be used to calculate mass. If this option is selected, the load will be divided by gravity and applied as a mass in the x, y, and z directions. In these units, a load of 386.4 applied in the minus z direction would result in a mass of 1. Added masses may also be assigned, in this case to the top-level joint objects, via the assign joint masses command. We will assign mass in only the local 1 or global x direction, and will ask the program to replace existing masses. The define mass source command specifies where the program should find the mass, from the elements and assigned masses, or from loads, or from both. If loads are selected, the user may apply a modifier. Note that the loads will have already been divided by the appropriate gravity factor. This example will use the element and added masses. We will not use the loads. The define analysis cases command selects the analysis cases. Delete the dead load case, as we will do only a modal analysis. Select the modal case and click on the Modify Show button. Here we can specify the type of analysis, in this case modal, the type of vectors to be used, eigen for this tutorial, the initial conditions, and the number of modes to be generated, which will be set to 2 maximum. Set the analysis option command to planar frame, and then start the analysis. Once the analysis is complete, the first mode shape is displayed. A click on the toggle button brings up mode 2. In addition to the graphical display, tabular results are also readily available. Go to the Display Show Tables command and check the joint output box. And then click on the Modify Show Options button. Here we can set the number of modes to be displayed from all to just the first. The joint displacements table generated shows the relative displacements for all joints for the first mode. Note that the maximum displacement in the x direction occurs at joints 3 and 9, which are located at the top level as expected. Note also that the displacement in the z or 3 direction is very small. Go back to the Display Show Tables command. Uncheck the joint output box and check the structure output box. Click the Modify Show Options button again and select all modes. The table of modal load participation ratios shows that we have full participation in the x direction, but that additional modes are required to capture the z direction response. This concludes this tutorial.